Hi, I'm Gerrit Lehr, Principal Cloud Strategist with the VMware Worldwide Multi-Cloud Architecture and Strategy team. And in this video, I want to talk about what a compelling VMware-based modern apps cloud platform can look like, both from the perspective of VMware Cloud service providers as well as VMware Cloud customers. Please take note of the disclaimer, especially because this video and the presentation contain financial comparisons and example calculations that compare different cloud services and are based on various assumptions. And depending on your own environment and assumptions, the outcome of these cost comparisons may differ significantly from what you're seeing in this video. So who's this video for and what are you hopefully going to learn? This video is really targeted at two types of audiences. One are VMware Cloud Service Provider partners that use VMware technology to offer and build cloud services for their customers. And the target personas here are Chief Technology Officers, business strategy leaders, as well as product managers, lead architects, and sales and pre-sales experts. And what these personas are hopefully going to learn is what the customer journey towards modern applications in the cloud looks like, and also what that cloud services market for modern application services looks like and who they are potentially competing with. That also involves competitive pricing models and customer focus when designing their offering, and most of all, building a compelling end user experience for their VMware Cloud consumers, which is actually the second target audience for this video. So if you're a CIO, head of IT, line of business IT leader, or a lead cloud architect or DevOps experts in a corporation that consumes VMware cloud services or really any cloud services at all, what you're hopefully going to learn is how do we think your cloud strategy from cloud first to becoming cloud smart. And that means finding the right cloud for any given workload, but also reducing your overall cloud costs, while of course enabling rapid application modernization for your application teams. And you probably want to do all of that in compliance with regulatory requirements and to remain in control of your overall cloud environment. So a little bit of background and introduction into what this whole video is all about. The basis of all of this is a white paper series that we created for VMware Cloud Service Provider partners called Building a Compelling Cloud Provider Business. It's a series of 4 white papers starting from how to build an infrastructure as a service offering and calculating the underlying total cost of ownership model. The second part was then about building a compelling modern apps and managed application business on top, so everything around Kubernetes and managed apps. Part 3 expanded the whole idea towards a multi-cloud and subscription business model, and part 4 was then really focused on multi-cloud DevOps and data services. So this series of white papers was exclusively targeted at VMware Cloud provider partners and contains some 100 pages roughly. So the idea of this video is really presenting and explaining the key findings of those white papers, both from a cloud service provider and an end customer's perspective. So we really want both sides of that business model to understand what a compelling modern apps multi-cloud can look like. But what do I mean by compelling? So first of all, we're going to look at features and functionalities, but focused on the value from an end customer's perspective. So while we're going to touch on technical capabilities, we don't want to get lost in the bits and pieces of the underlying technology. We really want to focus on what value a VMware Cloud customer is looking for and how to deliver that on the VMware Cloud platform as a cloud service provider partner. We're also going to look at the user experience from the end consumer. So that can be a developer, an operations person, or an application architect. And another dimension to compelling is then, of course, price competitiveness in the market. And when I say in the market, I mean compared to hyperscale public cloud providers, Amazon Web Services, Microsoft Azure, and Google Cloud. And I'm going to explain all of this to you, first of all, through the VMware Cloud Provider services that these providers can offer and the values that those deliver to the VMware Cloud customers. We also have a range of end-user experience demos and user interface walkthrough. So what does that look like in a real cloud service that customers might want to consume from these VMware Cloud Provider partners? And then we'll also have a look on the cost drivers and the pricing models for an end customer. And all of this is going to walk through three different types of services that are imperative in regards to modern applications, which are Kubernetes as a service, database and data services, as well as developer and DevOps platforms. Before we get started with those services, it's very important to first understand how the various cloud options that a VMware Cloud customer might choose from position themselves, and when a VMware Cloud customer would choose one over the other depending on the requirements that they have. So a VMware Cloud service hosting provider is oftentimes focused on regional customers, regional requirements, and builds specialized offerings based on the requirements that their customers in their respective regions have. Hyperscale public clouds, on the other hand, really have multiple services for each and every use case. So whatever your use case as a VMware Cloud customer are, it's very likely that a hyperscale public cloud has a solution or multiple solutions for that. VMware Cloud service providers also have a very close customer intimacy, meaning that they have close relationships with their customers and understand their requirements and shape their offerings accordingly. Hyperscale public clouds, on the other hand, focus on highly standardized services that look and feel the same across all regions and from the perspective of all different kinds of customers. VMware Cloud service providers are uniquely positioned to offer sovereign and compliant clouds depending on the regulatory requirements in their respective regions. Hyperscale public clouds, on the other hand, offer global scale. So there's very likely a data center available in each and every region of the world. If VMware Cloud consumers have a need and a requirement for familiar architectures, tool sets, and technologies, for example, based on what they already use in their data centers, they will very likely find that in the portfolios of VMware Cloud service hosting providers. Hyperscale public clouds focus, on the other hand, on highly innovative services, which a lot of times means that they have a bit of a proprietary nature to it. VMware Cloud service providers, in most cases, offer very predictable pricing, so it becomes relatively easy for a customer to anticipate the cost of their services. Hyperscale public clouds, on the other hand, have more of a very granular pricing model. So it's very flexible, but can sometimes get a little bit hard to anticipate the price tag at the end of the month. VMware Cloud service hosting providers also offer a range of managed and professional value-added services depending on their customer needs, while hyperscale public cloud providers in many cases will rely on a larger ecosystem of services partners to deliver those value-added services. So from the perspective of a VMware Cloud consumer or cloud customer, depending on what your application and services needs are, you may choose one over the other for any given workload. There are cloud providers which really fall into both of these buckets, meaning that they are hyperscale VMware Cloud service providers. And we also have a wide range of service providers that are VMware Cloud SaaS providers. A lot of times they will have predictable pricing. They build their services on familiar architectures, toolsets, and technologies from VMware, and also offer a range of managed and professional services on top. Still, the technology they're building on is highly standardized, available in a lot of regions in the world based on the VMware SaaS services, and these customers still focus on the close relationship and customer intimacy with their regional customers. So now that we have an understanding of how these different cloud providers position from the perspective of an end customer, let's look at the first service that we want to explore in this video, which is Kubernetes as a service. what kind of features and functionalities would customers typically be looking for, and how would they consume them from hyperscale public cloud or from VMware Cloud Service Provider partners. For Kubernetes as a service, we'll first of all need a Kubernetes as a service offering. So in the Amazon Web Services world, this is called Amazon Elastic Kubernetes Service, and it's charged on a per cluster control plane fee, as well as based on the number and size of worker nodes that run the Kubernetes and container workloads. And VMware Cloud Service Providers can basically offer the same thing based on Tanzu Kubernetes Grid in combination with VMware Cloud Director and the so-called Container Service Extension. So this gives VMware Cloud Service Provider partners the ability to offer a similar Kubernetes as a service experience as customers would find it in a hyperscale cloud. Now, in order to do anything meaningful with that Kubernetes cluster, customers will typically need a range of additional services: a container ingress and load balancing capability, Kubernetes backup, a container registry to store containers, Kubernetes aware and Kubernetes supporting monitoring, as well as maybe an application marketplace for easy deployment of containerized workloads. In the Amazon Web Services portfolio, there's a range of services that fulfill these requirements. So there's AWS Elastic Load Balancing, charged on a so-called per load capacity unit hour, so an artificial kind of charging metrics. We have Amazon Simple Storage Service, or S3, which is charged on a per gigabyte of storage basis in different tiers. Amazon Elastic Container Registry, again charged per gigabyte of storage and traffic. Amazon CloudWatch, charged on per event, per alarm, or per metric, or per dashboard kind of basis, so very granular, as well as the AWS Marketplace. VMware Cloud Service Providers, on the other hand, can offer the same set of capabilities with a couple of products from the VMware Cloud ecosystem. So there's first of all NSX in the base edition in combination with the so-called advanced load balancer. So that gives VMware Cloud Service Providers the ability to offer container ingress and load balancing capabilities for Kubernetes to their customers. And also there are a range of Cloud Director extensions and add-ons supported by VMware that VMware Cloud Service Provider partners can use in order to build backup capabilities with object storage extensions, App Launchpad and Bitnami as an application marketplace, as well as various supported open source components that we ship as part of Tanzu Kubernetes Grid for monitoring, registry services, logging, dashboards, and so on. So this is here what we see with Harbor, Prometheus, Grafana, and Fluentbit. There are similar service offerings in the ecosystem of Microsoft Azure. So this would be Azure Kubernetes Service, Azure Load Balancer, Azure Blob, Azure Container Registry, Azure Monitor, and the Azure Marketplace. And again, we can see on the left that there are various charging metrics which are sometimes similar, sometimes a little bit different to how AWS would charge those. And the same is then the case on the Google Cloud Platform with Google Kubernetes Engine, Google Cloud Load Balancing, backup for GKE charged on a per pod and per gigabyte basis, as well as the Google Container Registry, Google Cloud Operations as a monitoring and logging service, and the GCP Marketplace. So quite similar capabilities across all of the three large hyperscalers. Now what they all have in common is that you'll need a set of services which have quite granular charging and pricing mechanisms. Now what VMware Cloud Service Provider partners on the other hand can do is really bundle everything that a customer needs in order to build a fully functional Kubernetes service and offer it to customers as one compelling and very predictable Kubernetes bundle. So that would include the runtime, networking, backup capabilities, maybe monitoring and container registry. So a complete package, easy to use and in an easy to understand pricing model. So typically on a per VM and per gigabyte of storage basis. As an alternative or as an add-on, VMware Cloud Service Providers also offer various managed add-ons and managed services on top, either dedicated to each and every customer or in a shared services fashion. So VMware Cloud Service Providers have a broad range of potential managed services options that they can build and tailor to their customer needs here. Let's have a look at the user experience of consuming Kubernetes as a service from a VMware Cloud Service Provider partner based on VMware Cloud Director and the Container Service extension. We log into Cloud Director as a tenant user, so as the end customer that wants to consume Kubernetes services. The VMware Cloud Director user interface loads and presents me with the environment that I have so far and the resources that are consumed. And now when the end customer selects Kubernetes container clusters, they are presented with the overview of their existing Kubernetes clusters in their environment. So let's create a new cluster. We select the Kubernetes runtime, which in this case is Tanzu Kubernetes Grid. And we can see that this already includes layer 4 load balancing automation. So this is apparently part of the base offering. We give the new cluster a name, and we can select from various Kubernetes versions that the cloud service provider has made available to me as an end customer here. We select the networks that we have created previously in our virtual data center, and we can choose between whatever we have configured there. Is it a routed network? Is it a netted network? Let's select a private routed network for the example here. And now we can select the number of control plane nodes. So this is a bit different from the user experience you would get in a hyperscale environment, where you typically only have one control plane and you do not know how many nodes are behind that. So this has an impact on the pricing of the control plane, as we will see later on. So let's just select one node here, and the sizing policy gives us various options of TKG sizes to choose from. Now, for the worker pool that executes the containers, we could, for example, be offered GPU worker nodes. In this case, we don't have any, but the partner could also offer various sizes of worker nodes. So here we have extra large, large, and medium. So this is pretty similar to what we would find in the hyperscale portfolio with various instance types and sizes. So we just select a medium instance here. We don't have placement policies at the moment, and then we can select a storage policy, which again could correlate to different storage tiers. And we also have the ability to create additional worker nodes here in that creation assistant. So in this case, we just create one worker pool with one worker node. We'll select the storage profile, and we can also determine what kind of storage class name we want to present on the Kubernetes level, what the retention policy and the file system looks like to the Kubernetes cluster. We also have the option to configure the Kubernetes networks for ports and services, as well as control plane IP and virtual IP subnets. So here we can review all the configurations that we have made and click Finish to have the new Kubernetes cluster created for us. So while this creates, let's take a look at the existing cluster that was already in the environment. So here we can see the cluster name, Kubernetes version, control plane IP, virtual IPs, networks for Kubernetes workloads, and so on. So basically everything we just configured for the new cluster as well. What we can also see here is the node pools. So the pool of virtual machines that run the control plane and the virtual machines that run the worker nodes. So let's, for example, assume we want to resize the cluster and add additional worker nodes, additional container capacity to that cluster. So we simply change the number of worker nodes from 1 to 3. We submit the change, and then Cloud Director will automatically resize that Kubernetes cluster for us. So we can see it now has a target node count of 3, and in a couple of minutes, those additional worker nodes will be available for us. While that happens, we can observe the tasks down here in the recent task list, so we can see that Cloud Director created the additional worker nodes, it added them to the load balancing group, and just finished expanding the entire cluster so that additional capacity is available for the VMware Cloud customer to use. So when we now click at that cluster and go back to the node pools, we can see that there are now 3 worker nodes available in that Kubernetes cluster. So now that we have an understanding of the user experience for deploying Kubernetes as a service, let's have a look at packaging and pricing considerations. So when it comes to Kubernetes worker nodes, those would typically be priced with the same price point as non-Kubernetes virtual machines. So this is the common approach that hyperscalers out in the market take. And VMware Cloud service providers can leverage vSphere and VCD efficiency and over-provisioning mechanisms to offer various different virtual machine classes. So that could be compute intensive, memory intensive, or GPU accelerated, as we have seen in the demo. Now, for VMware Cloud customers, it's important to really compare against the right virtual machine class. So if you're comparing a high performance compute instance on AWS, Azure, or Google, you want to make sure that you're comparing against a similar virtual machine type in a VMware Cloud Service Provider environment. Now, when it comes to the Kubernetes control plane, hyperscale public cloud providers typically charge some 10 cents per hour per cluster, which is around 72 or 73 US dollars per month. What we need to be aware of are the different SLAs that come with that Kubernetes control plane charge. So those vary depending on the configuration, the architecture, and the cloud service you're using. VMware Cloud Service Provider partners can offer a similar SLA at a similar price point through single instance master nodes. As we have seen in the demo, we can choose between one or multiple master nodes, but even if there's only a single instance master node, that would be backed by VMware High Availability. So any failed master node would automatically be rebooted, allowing the VMware Cloud Service Provider partner to easily match those SLAs that customers may find in a hyperscale public cloud. And of course, VMware Cloud Service Provider partners can offer higher SLA simply by letting VMware Cloud customers deploy multiple master nodes and then charge accordingly at an additional price. When it comes to Kubernetes add-ons, it's very important to understand that the node prices from VMware Cloud Service Providers typically already include the capability to run as many load balancers and as many ingress controllers as you want. We have seen that in the demo as well, that the Kubernetes runtime already comes with those load balancing capabilities. Now, in the hyperscale public clouds environments, on the other hand, as we have seen, we'll typically get charged based on a per load balancer or a per forwarding rule kind of basis. So depending on how many load balancers you'll need per Kubernetes worker node, it may be very, very expensive to pay for those on a per load balancer basis. Whereas VMware Cloud Service Providers may have a higher price point for the base worker node VM, but that already comes with the capability to have as many load balancers as you wish. And then there are additional features to consider, which again, in the typical hyperscale cloud portfolios are charged on a very granular per service, per feature kind of basis, whereas VMware Cloud Service Provider partners can simply make those capabilities available to customers, instantiate those solutions in virtual machines, and then let customers do as much monitoring, logging, or create as many dashboards as they wish without having an additional cost associated with that. So this is the initial trade-off. Do you want a very, very granular pricing model, or do you want a more predictable pricing model, especially for those Kubernetes add-on services? So with that, let's look at the second demo, which is about VMware Cloud Director with App Launchpad, to show you an easy way about how VMware Cloud consumers, VMware Cloud customers can deploy containerized applications into those Kubernetes clusters. So we're back at the list of Kubernetes clusters that we have here. And the first thing we want to do when we hand off to an application operator or to a developer is download the kubeconfig file, which includes everything that an operator or developer needs to connect to that new Kubernetes cluster and interact with it. But maybe that application architect or that developer does not want to deploy Kubernetes workloads by themselves because they are concerned with developing applications and they don't want to manage the underlying infrastructure. Or maybe they are not familiar with Kubernetes interfaces. For that, we have the App Launchpad, which is basically an application marketplace to deploy virtual machine or container-based applications in an easy way. So this does not require any Kubernetes knowledge. So let's, in this example, deploy a Postgres SQL instance. But we could also deploy various open source projects that my VMware Cloud Service Provider has made available to the VMware Cloud customers. For this demo, we select Postgres SQL. And really all we need to do here is provide the Postgres instance with an application name. We select the target Kubernetes cluster. And then we have some advanced settings that we could configure. So this includes authentication, configurations, passwords for the Postgres user. We could configure additional user accounts, and we could also configure more details in the YAML file that we can see here. So this gives you a lot of flexibility to customize the deployment if you need that. Otherwise, it'll just be an easy to use default deployment. We could also enable replication at the number of read replicas and then simply launch the application into that newly created Kubernetes cluster. As we can see, in a few moments, that application has been deployed. So now we have created a Kubernetes cluster, we have instantiated a Postgres instance on it, and we have also downloaded the kubeconfig file. So now we have everything we need to connect to that Kubernetes cluster on the CLI using the kubectl command. So we can see these are all the nodes in that cluster, including the 3 worker nodes that we just added, or the 2 additional worker nodes. We can see all the different namespaces in here, and we can see that one of those namespaces has just been created, which is the Postgres instance deployed by App Launchpad. So let's look into that, and we can see that there is the Postgres pod running in there. So now, through a user interface, we have created everything that an application architect or a developer needs to interact with the cluster and with that SQL instance on a command line basis. And from here, the developer or the architect can interact with the cluster and explore more details about the deployment and start designing and developing a modern application on that Kubernetes cluster. We do, of course, have the capability to easily remove that application instance again in case the developer forgets about it. Maybe this is a test environment, or of course, to add additional applications to the environment. So since we've deployed a Postgres SQL instance, this is a really good transition to the second kinds of modern application services we want to look into, which is databases and data services. So these could, for example, be relational databases, something like Amazon RDS, which is charged on a per instance kind of basis. Maybe the application requires inter-service or microservice communication via a message queue or a message service. For example, Amazon MQ. We probably need some sort of caching mechanism, for example, Amazon Elastic Cache. And we might also need a data warehouse to do analytics and so on, for example, Amazon Redshift. And as we've just seen in the demo, we can leverage open source and Bitnami packages to allow our customers to deploy similar types of technologies on the VMware Cloud Service Provider platform through App Launchpad. However, it is very likely that, at least for production environments, VMware Cloud customers will need something more enterprise ready that is fully supported and has more capabilities compared to the open source free project. And this is where VMware SQL, VMware RabbitMQ, VMware Gemfire, and VMware Greenplum come in. So while all of these are based on open source technologies, there is enterprise support, additional capabilities, and additional IP from VMware going into these solutions, which really make them a very good fit for production-grade modern application environments. Now, as you can see on the left, the Amazon Web Services in this case are all charged on a per instance, per gigabyte of storage, and per traffic kind of basis. So this is relatively straightforward in terms of pricing and price predictability. However, when we look at the Microsoft Azure portfolio, for example, it becomes a little bit more complicated. So Azure Databases is charged on a per instance and per gigabyte basis as well. Azure Service Bus, on the other hand, has a per operation, per connection price tag that also comes in different tiers. Azure Cache also have different tiers and different cache sizes, and the Azure Synapse Analytics data warehouse solution is charged on a per Synapse commit unit, so again an artificial kind of metrics basis, as well as per data pipeline, per data flow, and so on. In the Google Cloud portfolio, it looks slightly different, but again, we can see that there are various different pricing metrics like per vCPU, per memory, per instance, and per gigabyte, as well as per analysis slot for Cloud BigQuery. For VMware Cloud Data Services, on the other hand, the main cost driver is the number of cores. So this is relatively easy to predict and anticipate for customers. It also means that using hyperthreading can greatly improve the total cost for these data services. Now, I've run a couple of example calculations that you can find in one of the white papers that you will see in the video links. And as a rule of thumb, when we compare those VMware data services deployed in virtual machines on a VMware Cloud Service Provider hosting platform, and compare it against the public cloud equivalents that we just looked at, VMware SQL tends to be in a similar price range or a bit cheaper. VMware RabbitMQ tends to be cheaper in most cases. VMware Gemfire tends to be maybe a bit more expensive, and VMware Greenplum tends to be cheaper or in a similar price range. Now, this is of course based on a range of assumptions that you can find in our white paper. However, in your own situations and based on your own assumptions, these results may be very different. So just be aware of that. What you also need to consider as a cloud customer is the multi-cloud deployment flexibility. So when you want to move from one cloud to another, whether that's your own cloud or a hyperscale cloud, VMware Cloud Data Services, so VMware SQL, RabbitMQ, Gemfire, and Greenplum, always look and feel the same because they can be deployed on any cloud, including hyperscale public clouds. And since those solutions are based on open source technologies, that also means that you can use free open source instances, for example, through Bitnami and App Launchpad for your test and dev environments, which will again save you some cost potentially. And the last consideration is whether to deploy those data services in virtual machines or in containers, where of course deploying in containers will decrease the per instance price in a lot of situations. So let's look into that in a bit more detail. What we can see here is an example of 12 data services instances deployed in 16 gigabyte virtual machines, which for example could be sold by a VMware Cloud Service Provider at a price point of $125 per instance. It's just an example. Now, when we look at a similar deployment based on containers, we get what we see here on top. So there would potentially be 3 Kubernetes worker nodes with 64 gigabytes each. So basically having the same resources as the virtual machines in the bottom situation. But we would have the data services instantiated in Kubernetes pods. And those could then be sold at a cheaper price point, for example, at $100 per instance. And that is possible because in many cases, VMware Cloud Service Providers are able to offer a cheaper price point for larger virtual machines in relative comparison to smaller virtual machines, simply because there are scaling mechanisms in the licensing and in the hardware which allow them to make larger virtual machines cheaper in relative comparison to smaller virtual machines. Now, hyperscale public clouds, on the other hand, in most cases scale their prices in a linear way, meaning that if a virtual machine is double the size of another virtual machine, it will also be exactly double the price. So this is a difference between most VMware Cloud Service Provider partner pricing models and the hyperscale public cloud pricing model, which then allows you as a customer to take advantage when deploying data services or really any other workload in containers compared to deploying it in virtual machines. So let's look at examples for both scenarios. We start with VMware Cloud Director and the Data Solution extension. to deploy a VMware RabbitMQ instance into containers. So we're back in the Cloud Director Kubernetes interface, and we can see that both clusters are now available. And now we move over to the Data Solutions interface. So we get first of all presented with a couple of dashboards where you can see if we already have instances deployed, and we can also see what kind of solutions my cloud service provider has made available to me. So in this case, this is only RabbitMQ in version 1.3, and we can also see that no clusters have been deployed yet, so we don't have any instances yet. The first thing the VMware Cloud customer needs to do is preparate the Kubernetes cluster for data services deployment. So we need to install the data solutions operator into that cluster, which then enables us to deploy data services. So we simply click install the operator, and it'll then automatically install that operator into the selected cluster. In this example, let's just do it for both clusters quickly. And once this is through, we can actually connect to that cluster and see that there is a new namespace, VCD DS system and workloads. So this is for data solutions and basically contains the operators that we have just instantiated here. So this is all we need to do. Now we can start deploying data services in containers into those clusters. So we give it a name, we select the cluster we want to deploy, and we can choose from different deployments like large, minimal, standard. Could be a cluster, could have different replicas, whatever my VMware Cloud Service Provider has offered me. And we can also configure the management console straight away, so we can give the service a host name, username, password, and we can also expose a load balancer for AMQP of that service. There are more options we could configure here in the editor. And once we click Create, the VMware Cloud Director Data Solutions extension goes ahead and deploys RabbitMQ in that example into that Kubernetes cluster. And it also supports additional data services like SQL. So once this is completed, we can jump back to the CLI or get our application architects and developers to observe what just happened. And we can see that now there is a new namespace called RabbitMQ system that contains those RabbitMQ components that we just deployed onto the cluster. We can also look into that and observe that there are different ports for the topology operator, the cluster operator, and so on. What the data solution extension also allows us to do is directly connect to the data services management interface. So in this case, we select Open Management Console, and it'll automatically send us to the RabbitMQ interface. We can log in and then start using RabbitMQ. Let's look at a second example of the VMware Data Solutions Manager to deploy VMware SQL, this time into virtual machines and not in containers. So the data management solution is a separate interface outside of Cloud Director service. So we log in again as a tenant, as a VMware Cloud consumer. And what we can see here is a full database as a service interface. So we select databases, and we can see a list of existing databases in our environment. And from here, we can select to create a new database. So this could be MySQL, Postgres, Greenplum, could even be Microsoft SQL in the latest version. So again, we give that instance a name, and we select the environment that we want to deploy into. So this could be my org VDC as a tenant, or it could be a shared services space of the provider. We select the VM configuration, so vCPU, memory, and storage sizes. And we can also select the management configuration. So do we want to have enhanced monitoring activated? Maybe this is a requirement for my provider to offer managed services on top. We can enable protection, version upgrades, and so on. The next step is then customizing the database connection settings. So having a database name, port number, username, password, as well as the virtual machine data store. And we can also configure automatic backup. So what's the time of the date that we want the backup to be included, and how long do we want to keep the backups. We also have the option to configure maintenance windows, so selecting a day and a start time and duration for the management window. We can configure SLA as a requirement for client connection, and we can have additional database configurations added here. So we simply review the configuration, create the database, and then it gets instantiated. The data management solution also allows us to do backup, tasks, database alarms, events, and so on. So it's a true database as a service interface. So now the test database that we just created is ready to use. We can see the status and all the details of that database that has now been deployed into virtual machines in my VMware Cloud Service Provider environment. And now I, as a VMware Cloud customer, can retrieve the credentials here and connect to that database instance, and again start modernizing my application with that SQL instance as a backend. With that, let's move to the last piece of this video, which are developer and DevOps platforms. So from a features and functionality perspective, VMware Cloud customers and their developers might need source code repositories. So in the Amazon Web Services world, it would be code commit. VMware Cloud service providers could offer GitLab. Customers also need CI pipelines like AWS Code Build or Jenkins. We probably want GitOps capabilities to automatically deploy and manage the infrastructure, for example, through AWS Code Deploy and Code Pipeline, or Argo CD in the open source world. And very likely that GitOps approach also includes additional automation and, of course, infrastructure as code and configuration management capabilities. In the AWS ecosystem, that would be CloudFormation as a free infrastructure as code offering, as well as OpsWorks as a per node chef or puppet configuration tool. And VMware Cloud service providers can offer similar capabilities based on either the VCD Terraform provider for infrastructure as code, or we could use ARIA Automation, formerly vRealize Automation, for advanced task automation and orchestration. And then one last piece to that developer and DevOps platform could be serverless capabilities to run functions and event-driven architectures. For example, AWS Lambda, which is charged on a per gigabyte second and per request basis. And VMware Cloud service providers could build something similar based on the open source Knative project. When we look at the Azure portfolio, the source code repository would probably be GitHub, which is charged on a per user, per gigabyte, or per compute hour basis. We can use the Azure DevOps and Azure Pipeline services for development pipelines. We can use Azure Resource Manager and Azure Automation for infrastructure automation and GitOps capabilities. And there is Azure Functions as a function as a service offering, again charged per execution time, per vCPU, or per memory duration. In the Google Cloud Platform, the source code repository again could be Git, could be something else. The CI pipeline would very likely be based on Google Cloud Build, which is charged on a per build, minute, and instance basis. We have Google Cloud Deploy that is charged on a per active pipeline basis, and then GCP Deployment Manager and GCE VM Manager for advanced infrastructure as code and configuration management, and Google Cloud Functions as a function as a service offering. Now, as we have seen before through the app Launchpad, VMware Cloud providers could choose to offer free open source packages that allow VMware Cloud customers to build these capabilities by themselves. But if customers want something more advanced and highly integrated, the offering here would be Tanzu Application Platform, which instead of having each and every feature that is required to build a DevOps platform as a separate service, Tanzu Application Platform simply offers an end-to-end software supply chain that already includes everything you need to build a secure path from code to production. So let's take a look at why having an integrated platform can be very valuable in a modern application practice for VMware Cloud customers. So here's an example from the AWS blog of what an example cloud-native CI/CD pipeline could look like on AWS. And we find a lot of services in here that we already talked about. EKS clusters, ECR as a container registry, AWS code build, AWS code deploy. But we also see additional open source component that we need, Tekton, Argo CD, and so on. So as you can imagine, stitching all of that together can be quite complicated and would potentially require a lot of engineering. Here we have a similar example on Azure, again from the Azure website. You can find the link down here, which includes, again, a lot of the Azure services we already looked at, but also things like Terraform. And a last example on Google Cloud, where we have GitHub, Cloud Build, Cloud Deploy, and additional services and open source components that we might need to integrate in order to get a true DevOps or CI/CD pipeline and platform up and running. Now, Tanzu application platform that is available to VMware Cloud Service Provider partners follows a different approach. It basically contains all the tools and technologies we need to build a full end-to-end developer platform on any Kubernetes. So this could run, of course, on the Kubernetes cluster that we just deployed in our demo, but it could also run on any other Kubernetes cluster, including the Kubernetes services we looked at in the hyperscale portfolio, Azure Kubernetes Service, AWS Elastic Kubernetes Service, or Google Kubernetes Engine. So Tanzu application platform is really agnostic in the sense that it can run on any conformant Kubernetes cluster. Now, from there, it really includes everything that Dev, Sec, and Ops teams need in order to modernize and run modern applications. So this starts from developer productivity tools, so-called application accelerators, integration into the software development environment. We have an API portal, we have catalogs of development projects to easily choose from, and we have the whole supply chain choreography. So a pipeline service, build service, convention service, as well as security tools that allow VMware Cloud customers to have a secure path to app delivery and to app production. And that all sits on the cloud native runtimes, so including serverless capabilities for functions based on Knative and other Kubernetes workloads. Now, one important thing to understand is that many of these capabilities that Tanzu Application Platform delivers are based on the most popular open source and CNCF projects. So these include Cartographer, Backstage, Tekton, Gripe for security scanning, Knative for serverless, Flux, as well as cloud native build packs. So in many cases, you would need to add these open source projects to the hyperscale portfolios if you want to build a true end-to-end DevOps platform. And Tanzu Application Platform already delivers all of that as part of one holistic solution. It is also important to keep in mind, especially when we compare total cost of ownership from a VMware end customer perspective, that there will very likely be several clusters and staging environments interacting. So in this example, we have a Tanzu Application Platform iterate cluster, which is where one or multiple developers connect to in order to develop and iterate new software features and functionalities. We also have build clusters, which turn this code into deployable artifacts. And then we have various run clusters representing the different development stages like quality assurance, user acceptance tests, and of course production. And we also have the so-called tab view cluster, which includes additional Tanzu Application Platforms components like the learning center, the user interface, and so on. So let's take a look at what that platform can deliver to VMware Cloud customers, both from the perspective of a developer and from the perspective of an operator. So in this demo, we're going to assume the Tanzu application platform is already deployed on any given Kubernetes cluster. So either my VMware Cloud service provider has deployed that Tanzu application platform instance for the VMware Cloud customer in the Kubernetes cluster that we have seen in the previous demo. This could, for example, be done through the Tanzu CLI or through Tanzu Mission Control. But another option could be that the VMware Cloud customer has deployed Tanzu application platform themselves on the cloud service provider's Kubernetes offering, or even on any hyperscale cloud. We're going to start in the Tanzu application platform interface as a software developer in the VMware Cloud customers organization. And here we want to create a new software project through what we call application accelerators. Application accelerators for VMware Tanzu application platform help a developer bootstrap new software development projects. And this catalog of application accelerators is pre-populated based on an enterprise architect's best practices, or maybe even by my service provider if this is a managed offering. So we can see a list of software development projects here, maybe Node.js, Java, or other projects. And in this example, we're going to deploy the Spring Sensors Java app. So basically, we give the new project a name, we select the image repository for the containers, and then this project is automatically generated for me. And as we can see here, we can explore the files right from the UI by choosing the Explore the File button here. So as we can see, this presents us with all the files pre-populated that we need to get that project started. We can also do the same thing from the Tanzu CLI, as you can see here. So we're going to create a new project from that generator, and then we download and unpack the files. And from there, what the developer would typically do is load those files into their integrated development environment, which in this example is Visual Studio Code. So in Visual Studio Code, the developer can now start working on the project, for example, this demo controller.java, which is the main file we're going to use when developing and iterating this application. But Tanzu application platform also comes with additional developer tools, for example, the tilt file that you can see here. Now, what this allows us to do is leverage the open source tilt project to enable the live update feature in Tanzu application platform. So we select live update start, and then Tanzu application platform and the Tanzu developer tools included in the Visual Studio Code extension here are automatically going to, first of all, build that project for me in the iterate cluster, but from there also keep the development project up to date and automatically reflect every change that the developer is making to that code, so that iterating and troubleshooting becomes seamless and easy for that development project. As I said, the underlying project here is Tilt, which basically automates all the steps from a code change to a new process. So that includes watching all the files, building the container images, and bringing the environment up to date to reflect those changes. So once this is concluded, and we can see the status down here in the integrated terminal tab, we have the application running in our development and iterate environment here for the developer. So we can see that the build is successful, and when we use the Tanzu CLI command, we can actually see all the resources running, including the pods and the Knative service, which exposes the application's URL. And from here, we can jump straight to our application that we just launched. Now, going back to the Visual Studio Code, let's assume the developer makes a change to that application, changing the banner title here, and that again automatically kicks off the live update process, meaning that this change is again automatically reflected in the development environment. So once this concludes, we can jump back to the application, refresh it, and automatically see the changes that the developer has made here. We can also explore the components and behavior of that application using the Tanzu application platform UI, maybe as an operator. So when we select that Spring Sensors app here, we can see the runtime resources. So that includes all the Kubernetes services, the Kubernetes deployments, pods, replica sets, as well as the Knative service with the URL for that application, as we have seen from the CLI before. And we can also drill down into each of these resources, see the status of the components. We can explore the various YAML file of those running resources, for example, for the Knative service that we can see here, and really retrieve all sorts of information that we might need in order to troubleshoot and observe that application. So as an overview here, we have all the annotations and labels that are associated with those Kubernetes resources. We can see the various pods that are running as part of that Knative deployment, and can even drill down into that particular pod here and explore all kinds of information using the Tanzu Application Platform live view. So getting details on the deployment, we can observe the health of the deployment, we can look at HTTP exchanges, for example, and we have various other sources of information, metrics, configuration, properties, caches, memory requests, threads, and so on. So once the developers are done iterating that application, they are going to commit those code changes to the Git repository where the application code is stored, as we can see here. What that does is it triggers the path to production on Tanzu Application Platform. So Tanzu Application Platform will pick up the changes made to that Git repository and automatically trigger all the steps needed in order to get that application rolled out into production. You can observe that in the Tanzu Application Platform UI here. We see that everything starts from the source provider, which is the code repository, and the second step is then a source scanner, which is Gripe in this case. We have an image provider, an image scanner, a config provider, and so on. And we can see how the application code needs to go through all these stages in order to be rolled out into production. And that happens fully automatically in an integrated fashion through Tanzu Application Platform. That is the main difference between using a platform and using a set of services that would otherwise need to be highly integrated in order to deliver such an end-to-end software supply chain. So once this is delivered to production, we can actually see that our application now has sensor data because it's deployed into a production environment. And we can also see here that that application data can also come from a VMware SQL database, as we have seen in the previous demo on data services and databases. So next, let's assume that the developer makes a mistake during the development of that application. Let's say, for example, they choose a library version that is known to have a critical vulnerability. So we'll change the version for that dependency here to 2.7.0, which kicks off the automatic build process again. And once we've committed that change, it also triggers the software supply chain from code to production. But what we can see here now is that the source scanner failed due to the change that we have just made. And that is because we have a policy in place that states that no package that is known for critical vulnerabilities can be deployed into production. And in this case, we have a remote code execution vulnerability here. So we can observe that live and then revert that change, which then allows our application to go back through that software supply chain and be deployed to production again. To conclude this video, let's take a look at the total cost of ownership for Tanzu Application Platform on Kubernetes from a VMware Cloud customer's perspective. We have seen the various clusters needed to run a full DevOps platform. We first of all have the iterate cluster for development iterations, where the developers connect to using their IDE and iterate new software. And just like the various run clusters for test, quality assurance, and production, these iterate clusters will scale based on the workloads deployed on them. So the more Kubernetes workloads I develop and run, the higher the cost for those clusters are, and so those need to be compared on a per cluster basis. Additionally, there are the build clusters and the view clusters. So the build clusters, as we have seen, take the developer's source code commit and applies a software supply chain that produces container images, Kubernetes manifest, and so on for deployment into run clusters. And these build clusters will see bursty workloads and high pod scheduling loads as each build or a series of builds kicks off. Now, for cost comparison, we will need to compare the cost for build cluster as well as the additional overhead for the view cluster with the various hyperscale public cloud services that we need as part of a software supply chain. And as we have seen previously, these are typically charged on a per build minute or build hour, as well as on an active deployment pipeline basis. So the first example comparison that you can see here really only compares basic hyperscale public cloud Kubernetes clusters plus load balancers, so Google GKE, Azure AKS, AWS EKS, with the VMware Cloud Kubernetes as a service offering and Tanzu application platform on top. So this is obviously not really an apples to apples comparison because Tanzu application platform, as we have seen in the demo, delivers a full end-to-end software supply chain and not just a Kubernetes cluster. And because of that, we can see that in some situations, especially in long-term commit contracts and for smaller Kubernetes worker nodes, the price comparison works in favor of hyperscale public cloud. So this is the gray bars you can see on top, where there is a price gap between hyperscale public cloud Kubernetes services and Tanzu application platform operated by a VMware Cloud service provider. And those costs will, of course, need to be recovered by saving on those additional services that we need as part of a full software supply chain. But what's also important to take into consideration is that building a true end-to-end CI/CD and DevOps pipeline, as we have seen previously, can be quite complex and involves a whole set of services in a hyperscale public cloud ecosystem. And the costs for setting up and stitching together that pipeline and integrate additional open source components like Tekton, Gripe, Knative, Argo, or Flux, and so on, will need to be taken into account for TCO comparison as well. So even if we only add 2 full engineering days to turn all those services and components into a fully integrated pipeline and a true software supply chain, we would already be able to recover the price gap that we can see in this illustration here. Now, all of this is based on an example calculation and various assumptions that may be significantly different for customers out there that have other assumptions and different environments. To additionally factor in those cloud and deployment services from the AWS, Azure, and GCP hyperscale portfolios that we have discussed earlier, this chart shows a range of scenarios ranging between 100 and 700 build hours per month and between 10 and 100 pipelines that are used to deploy. And as we can see here again, based on these assumptions, the break-even point would be around 150 build hours and between 10 and 25 pipelines when we compare a full Tanzu application platform environment on an example VMware Cloud Service Provider platform versus the equivalent resources used with AWS Code Build, Code Pipeline, Azure DevOps pipelines, GCP Cloud Build, and Cloud Deploy. So more build hours and more pipelines would work in favor of Tanzu application platform because you can basically run as many build jobs and pipelines as you want without increasing its cost beyond the pure resources underneath. Less build hours and less pipelines, on the other hand, would work in favor of hyperscale public clouds because that's the main charging metric for the services that we're comparing against here. But again, VMware Cloud customers will of course need to create their own TCO models and cost comparisons based on their own situation, technologies, and assumptions. I thank you for your attention. If you found this video interesting, please leave a comment and do not hesitate to reach out if you have any questions or suggestions.